guys, today we're going to explore why the basketball court, specifically its 3.9, is a fantastic example of a hyperbola. If you've ever wondered about the mathematical beauty behind this crucial element of the game, you're in for a treat. So, let's dive in and unravel the connection between the three-point line and the hyperbola. Let's get started. Before we delve into the three-point line, let's briefly review what a hyperbola is. So basically, a hyperbola is a conic section formed when a plane intersects a double cone. It consists of two distinct branches that are symmetrical about the center. So the standard equation of a hyperbola looks like this. Hyperbola is equals to the quantity of x minus h squared all over a squared minus the quantity of y minus k squared all over b squared is equals to 1, where h and k represents the center of the hyperbola and a and b are two positive constants that determine the size and shape of the hyperbola itself. So one of the fascinating aspects of the hyperbola is its asymptotes. So asymptotes are straight lines that the hyperbola's branches approach but never touch or cross. So these asymptotes intersect at the center of the hyperbola and help us understand the general direction of the branches. Another crucial element of the hyperbola is its foci. So basically, foci is the plural form of the word focus. Foci are two fixed points located inside the hyperbola. And the distance between the center and its focus is denoted by c, and it plays a crucial role in the properties of the hyperbola. Now you might be wondering what other real-world applications of a hyperbola have. Well, they used in various fields such as satellite communication, orbits, architecture, and economics. First, hyperbolas are utilized in satellite communication to determine the location of satellites. In orbital mechanics, it is used to describe the paths of the celestial bodies. In architecture, it is used to design iconic structures like suspension bridges. And lastly, even in economics, it is used to model the supply and demand curve. Hyperbolas are fascinating curves with unique properties that have practical applications in many fields. Understanding them allows us to grasp the elegance and beauty of mathematics at work in the real world. Now, let's look at the basketball court's three-point line, a defining feature that has revolutionized the game. The three-point line was introduced to encourage players to take more long-range shots. Now, let's have a trip down the memory lane and explore the rich history of the basketball court from its humble beginnings to the modern game we know today. The basketball court has evolved significantly. So for its early beginnings, the origins of basketball can be traced back to the late 19th century. It all started with Dr. James Naismith. He's a Canadian physical education instructor, and in 1891 he was tasked to create an indoor game to keep his students active during the cold winter months. So Dr. Naismith's original court was located in a gymnasium at the International YMCA Training School in Springfield, Massachusetts, USA. The first basketball game was played with a soccer ball and two pitch baskets as goals. So as for the first court, the first basketball court was quite different from what we see today. It was measured as 50 feet long and 35 feet wide, with a 9 feet tall pitch basket at each end. There was no three-point line, no key or paint area, and no backboards. As you can see, the early court was simple but revolutionary, laying the groundwork for the sport we love today. And over the years, basketball evolved, and so did its court. In the 1920s, the courts began featuring backboards, allowing for more dynamic gameplay. By the 1930s, the courts started to resemble what we know today, with mid-court lines and painted free throws. In the 1960s, the legendary coach and innovator Pete Newell proposed the idea of a three-point line to encourage long-range shooting. While in 1979, the NBA officially introduced the three-point line, and it has since become a defining feature of the game. Fast forward to today, and the modern basketball court has standardized dimensions set by various basketball governing bodies such as FIBA and NBA. A regulation NBA court measures 94 feet long and 50 feet wide, with a hoop height of 10 feet, and it includes the three-point line, key, and other markings to facilitate gameplay and ensure fair competition. As you can see, basketball is now a global sport played in countless countries with millions of enthusiasts worldwide. And the basketball court was once a simple gymnasium floor, has become a symbol of athleticism, teamwork, and passion. No matter where you go, the basketball court remains a place where dreams are made, legends are born, and the love for the game unites people from all walks of life. And there you have it, the captivating journey of the basketball court from its inception to the present day. The evolution of the court mirrors the growth of basketball itself, showcasing the game's cultural significance and its power to inspire generations. Now that we're done defining the hyperbola and have had a brief review of the history of the basketball court, we will now proceed to discussing how we can incorporate the hyperbola into the basketball court, specifically the three-point line. So the three-point line is an arc that extends from the baseline to the top of the key and wraps around the perimeter of the court. Its distance from the center of the hoop varies depending on the league. So it is 23.75 feet from the hoop in the NBA and 22.15 feet in FIBA games. Now, let's overlay the three-point line on the hyperbola diagram. What do we observe? So, the three-point line perfectly aligns with the hyperbola's branches. The three-point line is symmetrically equidistant from the center of the hoop, just like the branches of a hyperbola are symmetric about its center. Remember how we mentioned asymptotes earlier? These are straight lines that the hyperbola branches approach but never touch. Let's see if the three-point line resembles asymptotes. As we can see, three-point line closely resembles the hyperbola's asymptotes. Just like the asymptotes, players can keep shooting from long range without ever crossing the three-point line. Next, let's explore the foci. Those fixed points inside the hyperbola that play a critical role. How do they relate to the three-point line? So, the foci of the hyperbola align with the central point of the three-point line. This means that when players shoot from the center of the 3-point line, they are aiming at one of the foci, creating a direct line to the hoop. So, in summary, the basketball court's 3-point line exhibits striking similarities to a hyperbola. It is symmetrically equidistant nature from the center of the hoop, resemblance to asymptotes, and alignment with the foci make it a compelling example of this mathematical curve. So if you want to know what are the materials we use to create our 3D model of a basketball court, here are the list of materials we used. So for the court, we used an illustration board, an acrylic paint, and marker. So for the bleachers, we used a folder, and for the ring, we used glue gun and stick, of course, balloon stick, an illustration board, a paint, wire, and a bottle cup. As for the ball, we just used a sphere-shaped styrofoam and paint. For the direction, first, of course, we created the court's surface. We took an illustration board and we measured it and used the marker to mark the illustration board to create the court's area. Now, after that, we have painted the court with acrylic paint to give it a realistic look, creating the lines and colors of a basketball court. Next, for the bleachers, we used a folder. We measured and folded the folder strategically to form a stable structure for the bleachers. Next, after that, we make a basketball ring. And we used a wire and glue gun to mold the net. Thank you for joining me on this exploration of the 3-point line as an example of a hyperbola. I hope you've gained a deeper appreciation for the math behind the game, and until next time, keep shooting for success both on and off the court. Have a good day!
Hi guys, so since Julie has been discussed what's the hyperbola, the history of the basketball court, the connection of the hyperbola and the basketball court, the materials used for our 3D model which is the basketball court, and the directions of how we do our 3D model. Now I'm going to discuss to you how we do our 3D model using or applying what we have learned in the hyperbola. So our 3D model is not just drawn or made. We made sure that it will satisfy the standard equation of the hyperbola to make sure that it is really an example of hyperbola. But how do we do it nga ba? Let's answer that question. The first thing we do is we assume, since it is a 3D model, or most likely a miniature of a basketball court, we assume values that could satisfy the standard equation of the hyperbola. First, we assume the center. We assume that the center is at the origin of the Cartesian plane, which is located at 0, 0, since it will be easier for us to solve it, which will give us the equation x squared over a squared minus y squared over b squared is equal to 1. Second, we assume the values of A and B. We know that A is the distance from the center to the vertices, while B is the distance from the center to the whole vertices. Since we have limited space in our illustration board, we assume that the value of RA is 3 inches, while the value of RB is 5 inches. So it will not be too far or too near from the center. So by assuming that values, we will have the equation x squared over 9 minus y squared over 25 is equal to 1. The second thing we do is we solve. Since we already have the standard equation of the hyperbola of our basketball court, we can now proceed to solving. But before we solve, we must identify the center. And as I mentioned earlier, our center is located at 0 and 0. After that, we can now proceed in solving the other parts of the graph of the hyperbola. Now, we proceed by solving the distance of the center to the foci, which is c units is equal to the square root of a squared plus b squared. And we know that our a squared is 9 while our b squared is 25. Substituting the value, we can now solve it, which is c units is equal to the square root of 9 plus 25, which is equal to 5.83 inches. Now we rounded up that 5.83 inches as a whole number for us to easily plot it in the next step, giving us the C units as 6 inches. After getting the C units, we proceeded to solve the foci by adding and subtracting the C units from the x of our center, giving us the focus 1 at negative 6 and 0 and the focus 2 at 6 and 0. Then we solve for the vertices by adding and subtracting the value of RA, which is 3 in the x of our center, giving us the vertex 1 at negative 3, 0 and the vertex 2 at 3, 0. Lastly, we solve the covertices by adding and subtracting the value of b, which is 5, in the y of our center, giving us negative 5 and 0 and 5 and 0. The last thing we do is we plot. After solving all the values, we plotted it on our illustration board, giving us this 3D model basketball court.
眩しい日差しを背に走り出す街の中叩かれたいつものよう